Today we're gonna discuss more about classes, methods, types. So in this topic, we'll go deeper into some familiar concepts like variables, types, methods, and classes to enhance your understanding of C Sharp. So we'll explore more complex applications of these basic elements, though not all will directly relate to our current the example that we're working on. Instead, it will use some standalone examples to understand these advanced topics. So, as we cover new and potentially complex topics such as intermediate modifiers, method overloading, and the use of out and ref parameters, remember that it's okay to feel a bit overwhelmed. If that happens, you might find it helpful to review earlier chapters to reinforce your foundational knowledge. So this topic also shifts focus from Unity specific game mechanics to more general programming techniques. We'll look at how to work with interfaces, abstract classes, and how to extend class functionality. Also, we'll discuss how to handle namespace conflicts, type aliasing to keep your code clean and understandable. So, first topic is we are going to explore some more advanced ways to control how variables in C Sharp are used through specific keywords known as access modifiers. While you're already familiar with basic modifiers like public, private, there are several others that you might not use as often but are equally powerful in certain situations. So we'll focus on 5 key modifiers that can enhance your understanding of C Sharp and improve your coding skills. For now, we'll go into the first three: constant, uh, read only, and static. The other two are abstract and override. Will be discussed later in the context of object-oriented programming. So constant and read-only variables. So sometimes you'll need to use variables that hold values which shouldn't change once they are set. So this is where constant and read-only comes into play. So constant uh, you can use the const keyword when you want a variable to always contain the same value from the moment it is created. So this is particularly useful for values that are integral to the functionality of your program and do not change, like the number of maximum items allowed in a game, like public const int max items equal to 4. So a constant must be assigned a value when uh, when declared, uh, and cannot be changed afterward. And read only, the read only keyword is similar to the constant, but is similar to constant in that it is used for variables whose values should not be changed. However, unlike const and read only variable does not need to be assigned at the time of declaration. Instead, it can be assigned later, such as a constructor or initialization block. So this provides flexibility while still protecting the variable from changes. So by using these modifiers, you ensure that certain important values in your program remain unchanged after they are set. So protecting the integrity of your code and preventing bugs that might occur from unintended modifications. For more detailed information on all available modifiers, you can refer to the official documentation on the Microsoft website. So this foundational knowledge will serve as a springboard as we continue to explore other modifiers and advanced features in C Sharp. So next topic is static, the concept of using static keyword in C Sharp. So which serves a special role beyond the basics of object-oriented programming. Here we use on how static can be utilized to create uh, utility methods that and classes that do not require instances to operate. So this approach is particularly useful for functionalities that is common across different parts of your program, such as a method to restart a game level. So first, static classes. So a static class is one that does not need to be instantiated to be used. This means you don't create an object from a static class. Instead, you access its methods directly. Static classes are sealed by default, which means they cannot be inherited. This is useful for utility functions that are universal and do not need the variability of inheritance. And utility methods, these are the methods that perform general tasks, not tied to specific object instances. For example, a method to restart a game level can be used by various parts of your game, regardless of the current game state or object. Example is so when you start, let me take that example. So let's see how to implement this with a practical example in Unity. We start by creating a new script. Name it something like utilities, uh, and this script will house functions that are useful across different parts of the game. So inside the utilities class, we define static methods and variables that can be accessed globally without creating an instance of the class. We include necessary namespaces such as using Unity engine scene management to handle scene loading. We define the utilities class as a public static, indicating that all its members need to be static and it can be inherited. Inside, we add a static variable player deaths to keep track of how many items the player has. How many times the player has died. We also define a static method called restart level, which reloads the current level and resets the game's time scale to normal speed. And uh, and in the game behavior class, we should replace the existing restart logic with a call to unity utilities dot restart level within the GUI button checks. This explains the utility of the static method, which can be called using just the class name followed by the method name, like utilities dot restart level, without needing to instantiate the class. So by moving the restart logic into a static utilities class, we have made the code cleaner and more reusable across entire code base. This change emphasizes the power of static classes for creating easily accessible common functionality that does not depend on the state of any particular object in the game. So this setup not only streamlines the code but also makes it easier to maintain and update in the future. So as we continue, the use of static will be stepping stone into more advanced programming techniques such as method overloading and using ref and out parameters, enhancing your capability to write efficient and effective C# code. Next topic is method overloading. So uh, we dive deeper into more sophisticated use of methods in programming, which is method overloading. So this concept allows you to have multiple methods within the class with the same name but different parameters, thereby enhancing the functionality and flexibility of your code. We'll also see how this applies by using practical examples in our game development scenario. So method overloading. So method overloading lets you create several versions of the same method, each with a different set of parameters. So this is particularly useful when you want the same method to handle different types of input or operations without creating a new method name for each variation. For example, suppose you have a method designed to attack enemy. Let me open this. So you suppose you have a method designed to attack an enemy, and it looks like this. So the method signature, which consists of a method name and its parameters, and is attack enemy int. Uh, this signature is unique to this particular method. So now let's say we want to adapt our method to different gameplay scenarios, such as using different types of attacks or targeting different enemies. So by overloading the attack enemy method, you can create versions uh, that take different parameters without changing the method name. Let me give you the code. Okay. So it's just public full. Um, Let me edit this actually. So each method handles a different, significantly different situation, but uses the conceptually similar action of attacking. So in the context of our game example, the restart level method currently only restarts the current level. So however, as the game expands to include multiple scenes, you might want a more flexible approach to handle different scenes dynamically. So uh, here's how you can overload yeah, so here's how you can overload the restart level method currently in the utilities class to handle different game scenarios. So static void restart level, this method resets the game by reloading the scene and setting the game's time scale to normal. And The overload method, so this version allows you to specify which game scene to load, making the function more versatile. So in the game's UI, uh, so in the game's UI code, you can now choose which version of the restart level uh, to call based on different conditions. For example, when a player wins, uh, this line, this yeah, this line get this part of the code gets executed. Here we are calling the overloader method, specifying the scene index directly. And so method overloading is a powerful feature that not only allows your methods to handle different data types and amounts of information, but also keeps your code clean and organized. By using overloading, you can make your methods more adaptable to evolving needs of your application or game. So this is specifically useful in game development where different scenarios might require slightly different behaviors without the need for complete separate methods. Uh, Next is yeah, in this segment, we'll discuss how data is passed into methods in C sharp, focusing specifically on the ref keyword, which allows for passing arguments by reference rather than by value. So this is an important concept in programming because it affects how changes to variables uh, inside a method impact those variables outside the method. So the basics of passing by reference with ref is, you normally, when you pass a variable, to a method in C sharp, it's passed by value. So this means any modifications made to the variable within the method do not affect the original variable outside the method. So however, these are cases where you might want changes made inside the method to reflect on the original variable. So this is where the ref keyword comes into play. So some of the key points to remember with ref is variables must be initialized before they are passed to a method with ref. So unlike normal parameters, changes to ref parameters affects the original variable, and variables passed with ref can be modified within the method, allowing the method to efficiently return more than one value. And you cannot use properties that have get or set accessors as ref or out uh, parameters. So let's go. So to understand the use of ref, let's consider yeah. So let's consider updating a counter for how many times a player has restarted a game after dying. So here we have player deaths, which player deaths is a static variable that tracks the number of times the player has died and restarted the game. And public static, so this line, this part of the code, in the update death count, we pass player death uh, as a as a ref parameter, and which allows the method uh, to modify the original player deaths uh, variable directly. So the method increments the death count and returns a message including a new death count. And so within the restart level method, we first log the current number of deaths, and then uh, we call the update death count, passing the player deaths by reference. So this method updates the death count and returns a message which we log afterwards. Since player deaths is passed by reference, the original value is updated and the logs reflect this change. So by using a ref keyword, you can create methods that directly modify their input parameters. So this is particularly useful for situations where the method needs to update the state of an external variable, or when you need the method to affect multiple outcomes. So in our game, this functionality allows us to track and update the number of times a player restarts the level due to deaths, ensuring the game's logic and user feedback are consistently in sync. Uh, so next is out. So the out keyword in C sharp is quite similar to the ref, but it operates under a different set of rules, making it suitable for specific programming scenarios, particularly when you need to return multiple values from a method. So unlike ref, variables passed with the out keyword do not need to be initialized before entering a method. However, they must be assigned a value within the method before it returns. So this makes out specifically useful for methods intended to initialize a variable and return it along with other values. So an example, so let's look at an example to understand how out works. Uh, In this modified version of update death count method, we use out instead of ref. So this change allows us to set count references variable within the method itself, starting from the scratch, and the method sets count reference to 1 and then uses it to return a message indicating the player's next death count. So when to use out and ref is, you can use out when you need to initialize data within a method and return it. It's perfect for cases where the initial state of the variable is irrelevant and you're only concerned with the output the method generates. And you can use the ref when the existing value of the variable matters and you want to modify this existing value within the method. So yeah, that's the difference. So after exploring method features like out and ref, the discussion shifts back to object-oriented programming. So object-oriented programming is fundamental concept in software and game development, especially in C Sharp, where understanding how to efficiently use classes and objects is crucial. So object-oriented programming involves more than just using classes and structs. It's about designing your software in a way that's modular and reusable and adaptable. For example, while C Sharp classes support single inheritance, which is each class can only inherit from one parent class. They also provide tools like interfaces to allow for flexible and diverse object behaviors. So as we go deeper into object-oriented programming, you might ask yourself, how can I design objects from the same blueprint but have them perform differently based on a specific scenario? So this questions gets the heart of the advanced object-oriented programming, where you can use tools like interfaces, polymorphism to create versatile and dynamic systems. So understanding these concepts uh, will enhance your ability to design robust and maintainable software and games, opening up possibilities for solving complex programming challenges. Uh, let's let's discuss about interfaces. So in programming, specifically when dealing with complex systems like games, managing different types of objects and their behaviors efficiently is important. So interfaces in C Sharp offers a powerful way to achieve this by defining contracts or blueprints for what objects can do without dictating how they can do it. So let's explore how interfaces work and see an example of how they can be used in game development. So an interface in C Sharp is a structure similar to a class but serves as a different purpose. It's like a blueprint that dictates what behaviors, which are methods, and data is properties, a class or struct must implement, but it does not provide the actual implementation. Uh, let's discuss how what makes interfaces uniquely useful. First is no implementation. So interfaces contain definitions for a group of related functionalities that a class or a struct can implement, but they don't contain any implementation logic themselves. And flexibility. So classes or structs that implement an interface can still define their own behaviors and data, allowing for a high degree of flexibility. And multiple implementations. So unlike classes, which can only inherit from one base class, an object can implement multiple interfaces, making them extremely powerful for creating systems that need to work across different types of objects. So a practical example, let me open the code. So to see the interfaces in action, let's let's discuss one that could be used by various manager scripts in a game to ensure they share a common structure. So iManager. So this is the name of our interface, and it includes a state property. It includes a property called state, which with both getter and setter. This means any class that implements iManager needs to be able to tell you its state and allow you to change it. And we also have a initialize method. It also defines a method initialize that every implementing class must define. This method is meant to set up initial conditions or configurations. So the interface keyword is used to declare the iManager is an declare that iManager is an interface. Uh, Inside the interface, we declare what properties like state and methods like initialize are required for implementing classes, and properties in the interfaces can include access modifiers for get and set, providing on whether you need read only, write only, or read write access. So once the iManager interface is created, any class that needs to act as a manager can implement this interface. This implementation forces the class to provide the specific properties and methods defined in the interface, uh, thus adhering to common contract, which in turn makes managing different types of managers easier and more predictable in broader system. So your next step would be implementing to implement this interface in any class that acts as a manager. For instance, a game manager or enemy manager class would implement the iManager interface, providing a specific implementations for the state property and the initialize method as per the needs of their specific functionalities. So, interfaces are vital part of object-oriented programming in C Sharp, providing a way to enforce certain functionalities across multiple classes while allowing for individual differences in which those functionalities are executed. So this makes your code more modular, easier to manage, and adaptable to changes, which is specifically valuable in game development where different systems need to interact seamlessly. So we'll discuss the rest of the topics in the next session.